Hello and welcome. Today we have an interesting problem to tackle. We have a code snippet that exhibits some odd behavior when the std is underscore sorted. Function is called twice in a row. The first call returns false, and the second call returns true, which is quite puzzling. This issue has been observed on various versions of Apple Clang and Ubuntu Clang, all while compiling with optimizations and different C++ standards. The code in question uses a sort algorithm to sort a std array, and then checks if it is sorted using std is underscore sorted. The strange behavior only occurs under certain circumstances, and we're here to investigate further. Now, let's delve into the solution for the problem at hand. The root cause of the issue lies within the insertion-sort function, in a while loop where we compare j with begin and check if *j key. There's a subtle problem. The iterator j is decrement when it's equal to begin, which leads to undefined behavior. This can be remedied by ensuring that j is not equal to begin before decrementing it. By rectifying this small but crucial detail, we can eliminate the unexpected behavior caused by this undefined operation. Building upon the previous solution, we can further enhance the insertion-sort function for more robust and reliable sorting. By implementing a revised version of the function, which includes additional safeguards and optimizations, we can ensure consistent and correct sorting behavior. This updated version of the function incorporates best practices and avoids the pitfalls that led to the initial erratic results. With these improvements in place, the sorting algorithm performs as expected, producing the desired sorted output with no unexpected deviations. Continuing with the enhanced sorting function, we can witness the positive outcome of our modifications in action. When running the updated code snippet, we can see the array elements properly sorted in ascending order. 1, 2, 3, 4, 5, 6. Additionally, both subsequent calls to std is underscore sorted now return true, indicating that the array is indeed sorted correctly. This successful outcome highlights the importance of addressing even the smallest nuances in our code to avoid unexpected behaviors and ensure reliable performance. Taking our solution one step further, we can optimize the insertion-sort function by utilizing the std bidirectional iterator concept. By incorporating this more specific iterator type into the function template, we can enhance the code's clarity and efficiency. This refinement helps to streamline the sorting process and maintain code consistency, ultimately leading to better overall code quality and performance. With these enhancements in place, the sorting algorithm operates smoothly and reliably, delivering the expected results consistently. In conclusion, by identifying and rectifying the subtle issues within the code, we have successfully resolved the perplexing behavior observed during consecutive calls to std is underscore sorted. Through diligent attention to detail and strategic enhancements to the sorting algorithm, we have achieved a stable and accurate sorting mechanism. With these improvements implemented, the code now functions as intended, producing the correct sorted output without any unexpected variations. Thank you for joining us on this coding journey, and remember to like, subscribe, and comment with your thoughts. Happy coding!